Roguelite Unity tutorial. In the last video, we implemented our binary space partitioning algorithm to generate some rooms for our dungeon. Today, we're going to connect our rooms with hallways. We're going to break down how the code works and explain the logic behind it step by step. So this will be a key feature to create connected spaces for our game. Before we dive into the code, let's take a step back and look at what we're trying to accomplish. I prepared some visuals to help us understand the overall goal of connecting rooms in a dungeon. So first, we'll imagine that the dungeon is a grid, and each of these rectangles are going to be our rooms. These rectangles can appear anywhere on the grid, and it's our job to connect them. So here's an example of a room configuration that we could generate, and each rectangle has a center point, represented as a coordinate pair. These coordinates will serve as our starting and end points for connecting rooms. Next, we need to ensure that every room is connected to at least one other room. To do this, we'll find the closest connected room to the current unconnected room. Let me show you what that looks like. So in this example, we have our room center here, and we're going to calculate the shortest distance to each of our unconnected rooms. So first, we'll have this one, which is a distance of 9. We'll have our second one, which is a distance of 14. And lastly, our third one has a distance of 20. So 9 is obviously the shortest distance, so we'll work on connecting that room first. Okay, so once we have calculated the connected position, we're going to go ahead and add a tile to our tile map so that those rooms will be connected. Next, we're going to help the dungeon feel a little bit more organic and less predictable by adding some extra connections between our rooms. For instance, we might connect a room to another randomly chosen room nearby, even if it's not the closest. So these extra connections will ensure that our dungeon feels more like a natural winding labyrinth than a strict tree structure. To accomplish this, we're going to again start at our room center, and we're going to decide how many connections we want. So in this case, let's pretend that we randomly generated the number 1. Right? So we're going to connect this room to a single room. Then, starting at our room center, we're going to decide which room we can connect to. And this is going to be a random room in our connected rooms list. So we can't connect to ourselves because we're ourselves. And we can't connect to the room that we were already just connecting to. We want to pick a different room. So that leaves us with one option right here. Once we've selected which room we're going to connect to, we're going to go ahead and calculate where that room center is and calculate our path to get there. Once we have our path calculated, we'll go ahead and we'll use our tile map visualizer to instantiate our tiles onto the grid, and we will have 2 connected rooms. When we're done, we will have a fully connected dungeon where every room is accessible. Some rooms will have multiple connections, and others might just have one. The idea is to make our dungeon exploring feel more interesting and unpredictable. Now that we've seen what we're trying to accomplish, let's go ahead and jump into code and bring this to life. So let's go ahead and head over to Unity. And we will open up our dungeon generator script, and we'll scroll down to our generate dungeon function. So we're going to go right here after our floor positions, and we're going to create a new list of vector2 ints to hold all of our calculated room centers. We're going to use this later to connect our rooms. So let's go ahead and we'll type list vector2 int. We'll call this room centers. And we're just going to set this to a new vector2 int list. Okay, so now that we have our list, we're going to go ahead and loop through each of our rooms in our rooms list so that we can calculate the room centers. So we will add a for each loop right below, and we'll loop through each room in rooms. And so for each of these rooms, we're going to calculate the center of the room. And we'll use a vector3 int to hold our calculated position. So we'll say room center. And we're going to use a function inside of vector3 int called round2int in order to calculate this. So we'll say vector3.round2int. And then our bounds for our room actually already contain a center, so we're just going to use that. So we'll use room.center. Okay, so now that we have our center of the room, we need to go ahead and add it to our room centers list. So right underneath our room center, we'll say room centers, plural, make sure it's the list. Then we'll add it. And in order to add it, we need to cast from a vector3 int over to a vector2 int because our list is expecting a vector2 int. So we'll create some parentheses and we'll type in vector2 int. And then after that first set of parentheses, we'll type in room center. Okay, so that will have our room centered added to our list. Once we get all the way through that loop, we'll have all of them calculated. So next we're going to connect our rooms. So we'll need to write a function to handle this for us. But for now, let's create a hash set to hold all of our calculated corridors. So we'll go hash set, and this will hold vector2 ints as well. And I'm going to name mine corridors. And instead of setting that to a new hash set, I'm going to just kind of say which function we're going to be connecting to. So that will be connect rooms. And this function will need all of our room centers enabled to be able to connect all of the rooms together. So we'll pass that in. So we'll say room centers. Okay, so now that we have that, let's go ahead and use command period to open up our quick fix menu. Or if you're on Windows, it's going to be control period. And we'll go ahead and just click generate connect rooms. And that's just going to generate our connect rooms method for us. So let's go ahead and go down and delete out that exception, and we'll start our connect rooms logic. So this method is going to return a hash set of vector2 int to our caller. So let's go ahead and create a hash set that will hold our end result at the top of the function. So we'll say hash set vector2 int, oops. And I'm going to call mine corridors. We'll just set that to a new hash set of vector2 int. So we're also going to need to keep track of which rooms we've connected to and which rooms that we still need to get connected. So we're going to create two lists to do just that. First, we're going to create a list of vector2 int, and this one will be our connected rooms. And we're going to set this equal to a new empty list of vector2 int. And our second list is also going to be a list of vector2 int. And this will be our unconnected rooms. And I'm just going to put an S up there because I forgot it. All right, and then with this one, we are going to create a new list, but it will not be empty. We're going to copy our room centers list into this list as we create it. So that way every room is unconnected. So we have that populated for us. So for our unconnected rooms, with that populated, we're going to then shuffle this list so we can add some more randomness to our connections. So let's go ahead and do that. To do this, we're going to create an extension method so that we can call the shuffle function with the dot operator. So let's go ahead and open up our file structure. And in our scripts folder here, we're going to right click and create a new folder. And I'm going to call mine extensions. So any extension that we create will live in this folder. So inside of the extensions folder, let's go ahead and create a new C# script. And I'm going to call mine list extensions.cs. And this is going to create an empty file, so then we need to fill in our using directives that we're going to need. So we'll use using Unity engine and also using system.collections.generic since we're going to be using lists. Then we need to add our class to the file. So this class is going to be static, so we could say public static class list extensions. And we don't need to worry about inheriting from monobehavior or anything since this is just gonna live in our back end. So next we're going to add our shuffle method to the class. Because our class is static, the method must also be static. So we'll say public static void. And the name of our method is going to be shuffle. Okay, so in order to make this work on any list that we're going to use this on, we're going to need to use generics. Using generics will allow us to use this method on any type of list. So we're essentially going to infer what type we're using from the list itself. To do this, we need to add some angle brackets right after our shuffle, and then we're going to give this a valid identifier. So you can give it any one that you like, but typically it's pretty common practice to use T. Next, we'll add our parameters, so we'll add our parentheses, and since we want to be able to access this method through the list we want to apply it to, we need to use the this keyword. Next, we'll then declare the type of list it is, so we'll say list, and we're just going to use our generic type that we declared earlier, and then we'll name our list, and because we want it to be as generic as possible, I always just name mine list. Right, great. So now that we have that set up, we'll go ahead and fill in our logic. So inside of our function, we can loop through all of the items in the list. So we'll say for int I equals 0, I is less than list.count, list.count, and then we'll just increase I. Then inside of our for loop, we'll choose a random index in the list and then swap out our current index value with the random one. So to do that, we're going to first generate a random index. Okay, and we'll use random.range to do that. So let's say random.range from 0 to the list.count. Okay, next we'll go ahead and create a local variable to hold the value of our current index. So here we're going to use the generic type so that the function can be used by all types of lists. So then this will just set to list I. Then we're going to go ahead and set our current index in the list to the random index. So we'll say list I equals list random index. And lastly, we're going to set the random index to our temp value. So essentially, we're just swapping two items in the list over and over until we've done that as many times as there are things in the list. So now that we have our shuffle logic in place, we're going to go ahead and call the function through our unconnected rooms list in our connect rooms function. So let's go here. Underneath our connected rooms, we'll just say unconnected rooms.shuffle, and that's going to shuffle our rooms. Next, we will take the first room in our unconnected rooms list and we're going to add it to the connected rooms list. So we'll say connected rooms.add unconnected rooms at index 0, and then we can remove that list from our unconnected rooms. So we'll say unconnected rooms.remove at 0. So now we're ready to connect the rest of our rooms. So we're going to use a while loop to keep processing our rooms until all of them are connected. So for each room, we're going to find the closest room in connected rooms using a helper method. Then we're going to create a corridor between the current room and the closest connected room. And then we're going to optionally add some random connections for variety. So we're going to start by creating our while loop. And our condition will be unconnected rooms.count is greater than 0. So that means we're just going to keep looping until we've processed all unconnected rooms and there's no more rooms that are unconnected. Then we're going to get the current room by taking the first item out of our unconnected rooms list. So we'll say vector to int current room equals unconnected rooms at our position 0. There we go. And then we'll go ahead and remove that room from our unconnected rooms list. Okay, so then we're going to get our closest connected room to our current room. So we're going to create a local vector to int variable, and I'm going to call this closest connected room. And we're going to actually get this value from a helper function called find closest room. And this find closest room function will need to take in our current room and our connected rooms list in order to find the closest room. So we'll pass in our current room and our connected rooms list. And now that we've got that all filled out, we can go ahead and use our quick fix menu. So command period, or on Windows, it's control period, to generate this find closest room method. And that will just generate here below. Okay, so now that we've got that generated, we're going to just keep going, and we're going to add our room corridor to our corridors list. So essentially what we need to do is we're going to do two things in one step here. First, we're going to say corridors.add, union with, because we don't want any repeats. And then we're going to call a function to get all of the corridor floor spaces. So this will be create corridor. Okay, and our create corridor function is going to need a couple of things in order to figure out what corridor to build. So we're going to give it our closest connected room, and we're also going to give it our current room. Okay, so now that we have that, we can also use our quick fix menu here to generate that method for us, and that will go here below. Okay, so then what we'll do is we'll decide if we want to add any more connections between rooms. So to do this, we're going to use random.range to generate a number between 0 and 3. So we'll say int additional connections equals random.range, not random range, and then we're going to go from 0 to 3. So this means we'll be able to randomly connect between 0, 1 connection, or 2 connections from our room, since the 3 is not inclusive. And then after we get this, we're going to check if we got more than 0, because if we have 0, we don't really need to do anything. So we'll say additional connections greater than 0. So if we do have some rooms to connect, we also need to see if there are connected rooms to connect to. So we'll add a AND condition here, AND operator, and then we'll say connected rooms.count is greater than 1. So if we have at least one room in there, if we have more than one room in there, then we'll connect. Because if we only have one room in there, that means that it is we don't have enough rooms, because it was the room that we connected to previously, so we don't want to do that. So if we do need to add additional connections and there are enough rooms to connect, then we're going to loop through the number of connections that we need to add. So we'll say for int I equals 0, I is less than additional connections, I plus plus. And then we're going to go ahead and add our connection logic into our for loop. So we will get the random room from connected rooms. So we can say vector to int random room equals connected rooms. And then we'll use random.range again to get a random index in that list. So we'll say random.range. And we'll go from 0 to connected rooms.count. Okay, so now that we've got that, let me just close this so we have more room. Okay, so now that we've got that, we're going to check if this random room is also not the connected room that we just did, because we don't want to connect it again to the same room. So we'll say if random room does not equal closest connected room, then we'll go ahead and we'll create the corridor, and then we'll add it to our corridors list. So we'll say corridors dot union with, and this is the same thing that we wrote up here, but it's going to be slightly different. So we'll say create corridor, and then instead of our passing in our closest connected room, we're going to pass in just our random room and then also our current room, and that will add that additional random connection. Okay, so then after that, we can add the room that we connected to our connected rooms list. So we want to make sure that we're outside of this function, outside of this if statement here. So we're going to add that to the bottom. Dot add, and then we'll just add our current room to that. All right, so finally we'll need to also return our corridors. So to the bottom of this function, make sure that you're outside the while loop here, and we will add return corridors. So the loop will ensure that all our rooms are connected, and it will also add some randomness and variety. So next we're going to add the logic for the find closest room function that we created earlier. So to start, we will default our closest room to the first room in our list. So we'll say vector to int closest room equals connected rooms with the index of 0. And then we're also going to define our default distance, like the shortest distance, to the maximum of that we can. So we'll say float shortest I can't even spell today. Shortest distance equals float.max value. Okay, so after that we're going to loop through each of these rooms that we passed in here. So we'll say for each, oh my gosh, var room center in connected rooms. Okay. And then we'll calculate the distance between the current room and the next room. So I'm actually going to change this from room center to just room. It technically is the room center, but I think it makes more sense to just have room. So, okay, so now let's calculate distance. We'll create a float, call it distance, and then we're going to use vector2.int.distance to calculate the distance between our current room and our room that we're currently processing. So after we calculate the distance, we'll check if distance is shorter than the shortest distance. And if it is, we will go ahead and set our closest room equal to the room we're currently processing. And then we'll set our shortest distance equal to the distance that we just calculated. Okay, so after we've processed each of the rooms, we're going to go ahead and return the closest room. So we'll say return closest room. And yeah, you want to make sure that that is outside of our for each loop, just at the end of our function. So next we're going to fill in the logic for actually creating our corridors. So let's go ahead and head up to our create corridor function. And this method is going to build L-shaped paths between two rooms. So to start, let's go ahead and change our second parameter from current room to destination, because I think that will make more sense as we're coding this instead of current room. Okay, and then we're going to add a corridor hash set to the top of our function, since we're going to be returning that, and this will be a vector to int, and we're going to call it corridor, and this is only going to contain the floor positions for a single corridor, so that's why we're calling it that. We'll set this to a new hash set. Okay, so right away I see that this is returning an IEnumerable, which is fine since a hash set is in IEnumerable. But if we want to just be more specific, we can say hash set here as well. Okay, so then we'll need to store the room center in a local variable as our starting position. So let's go ahead and just go down and we'll say vector to int position equals our current closest connected room. Okay, so then we will add this position to our corridor hash set. So we'll say corridor.add position. And then we're going to use a while loop to loop over all of our y positions until we reach the destination. So we'll create a while loop. and we'll say we're going to loop while position.y does not equal destination.y. All right, and then inside of our while loop, we're going to go ahead and check if our destination's y position is above or below our current position. So we'll say if destination.y is greater than position.y, then the destination is above where we currently are, so we will need to move towards our position, which will be up. So we will add our vector to int.up to our position. So if that's not true, we'll check to see if our destination is below where we are. So we'll say destination.y is less than our position.y. If our position is below where we currently are, we're going to add we'll move down towards that destination. So we'll add a vector 2.int down to our current position. And then once we've calculated what our new position should be, we're going to add it to our corridor. So we'll say corridor.add position. Okay, so once we've looped through all of them until we hit our destination y, we'll continue to do that. Then after that while loop, we're going to create another while loop. And this time we're going to check our x. So if our position x does not equal our destination.x, we're going to keep looping, and we're going to loop through all of the positions on the x until we find our destination. So this logic is going to be largely the same. So I'm going to go ahead and copy this if else into here. And then we're just going to change anywhere that says y to x. So do that here and here as well. And then instead of up and down, if our destination.x is greater than our position.x, it means that the destination is to our right. So instead of using vector2int here, we're going to use right. And then if our destination is less than our current x position, it means that the destination is to our left. So we'll add the left direction to our position instead of down. And then of course we're going to add our position to our corridor. Okay, and then once we have calculated all of those positions, we will go ahead and return our corridor. So make sure you're outside of this last while loop. And we can just say return corridor. All right, so now we've implemented the entire process of connecting rooms. So let's go back to our generate dungeon function, and we'll make sure that our corridors get added to our floor positions hash set so that they'll be drawn on the tile map when we generate our dungeon. So back in the generate dungeon function, we'll go ahead and right under where we have corridors, we'll say floor positions dot union with, and then we'll add our corridors. So let's go ahead and save our script and head back to Unity to test things out. All right, so back in Unity, we can select our dungeon generator from our hierarchy, and we'll go ahead and just click our generate dungeon button to see if that works. So I'm going to go ahead and switch over to my scene view so I have a better view, and I'll click generate dungeon, and you can see that now we have those connections between our rooms. So we'll do it again and again, and you'll see that this is fairly random. This is looking pretty good. All right, great work, guys. So you can customize this further by tweaking the randomness or corridor creation logic to suit your dungeon's needs. But for now, in our next video, we're going to be implementing our wall generator so that the walls will be created to match our floor layout. Thanks for following along, and don't forget to like, subscribe, and hit that notifications bell so you won't miss anything. I'll see you next time.